Right, so today we're going to do introduction to statistics. This is our first lesson in statistics, and we'll be doing introduction to statistics. And this is a simplified way of learning statistics, and I'll make sure to explain every part that might give you difficulties and that has been giving students difficulties. I'll handle this topic so simple as it is. The simplest topic in statistics, introduction to statistics. We are actually going to look at the statistical measures. That is, we're just going to look at the mean, the variance, the standard deviation. Yeah, those are the things we're going to look at. So my name is Dr. Consistency. Let's begin the lesson. So introduction to statistics. So in this chapter, as already here, with most of the common used average. So the arithmetic mean and the standard deviation are the things we are going to actually discuss in this lesson. So the mean, the arithmetic mean. So suppose we have a sample of 10 measures, okay? So we are going to have the sample of 10 measures. So let's have the first sample, which is 2, 3, 3, 4, 5, 5, 5, 6, 6, 7 centimeters. These are the measures that we have. And then we are asked now to find the mean. What will be the mean? What will be the average of these numbers? So the mean is simply the average of the measures that we have here. So here the answer is 4.6. How did we get 4.6? That's the question that we need to address. How did we get to 4.6? So if we make n a measurement, okay, it will be x1, x2, x3 up to xn, which means all the measurement that was given in the data set. The sample mean is then given by, okay, we want to find out how we found that 4.6. The sum of all the measurements divided by the n. What is n? N is the total number of the measurements that we have. So in this case, in our first example, we have 10 measurements, okay? We have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is our n, okay? We want to calculate the mean. We want to find the mean. So what are we going to do? We know that where there's n, we'll put 10. How many do we have in the sample? How many items or how many measurements do we have? There are 10. But we add now the individual elements together. So we're going to add 2 plus 3, 5, 5 plus 3, 8, 8 plus 4, 12, 12 plus 15, okay, 12 plus 15, it will be 20, 12 plus 15 is actually 20, 27, 27 plus 6, so 27 plus 6, it will be 30, 33, 33 plus 6, 39, 39 plus 7, it is 46, okay, it is 46. Now we have the total of these measurements to be 46. So now to find the mean, we're going to say x bar, to mean the mean, will be equal to the sum, which is 46, over n, which is actually 10. So the formula for mean is the x bar equals to the summation of the values that we have. So in this case, we're going to say summation of x over n. So in our example, the sum is 46. Divided by n, how many items do we have? There are 10. So 46 divided by 10, that's the one that gave us a 4.6 that we actually have that we have here. So that's about the mean. Simple, right? So we move on to the mean of a simple frequency distribution. So Right set of data will normally be arranged in frequency distribution, and thus the formula for the mean is given in previous C. Example is not quite appropriate since no account is taken of frequencies. So this one is just a direct way of calculating the mean. The formula that we presented here is direct method of calculating the mean. But then, where we are given large data set, this formula may not work. So let's get this data set. We see the example. So consider the following: the discrete frequency distribution, determine the mean. So we're given this, we're given the f, the frequency, and the x, okay? And then they want us to calculate the mean. Alright, what are we going to do? So in this case, our mean will be equal to the sum of f of x over n. Okay, you see now the formula we have introduced is the f. In the previous, the formula was just sum of x over n. It was just sum of x over n. But when we're given frequency distribution, it will be the sum of f of x over n. So f of x simply means we multiply the frequency multiplied by the x. Frequency multiplied by the x. So what we have here is the frequency. For the first value of x, we have 2 multiplied by 10. Then we get the sum. So we multiply these numbers. So we have 10 by 2 plus 12 by 8. You can see the values here. Plus 13 by 17. These are the values we're talking about. Plus 14 multiplied by 5. This is what we're talking about. 16 multiplied by 1. And then plus 19 multiplied by 1. Final. So when you compute this on the calculator, we'll get a 442. So this 442 now, we're going to divide it by n. Okay, now, our n, how many in total do we have? Alright, so we have 34. Alright, we have 34. Okay, we have 34. So we divide 442 by 34. We get 13 as our mean. Note that the mean for grouped data, grouped frequency distribution x is the class midpoint. So let's look at grouped data. So the following data relates to the successive sales made by salesmen employed by large Moroccan PC firm in particular quarter. So we have been given that x 0 to 4, 1, that's the frequency distribution, 5 to 9, 14, 10 to 14, 23, 15 to 19, 21, 20 to 24, 15, 25 to 29, 6. Calculate the mean number of cells. So this is a grouped data. You've seen, eh? So for a grouped data, this is what we do. We will make sure, already we were told that to calculate the mean for a frequency distributed data, we will say the sum of f of x over n. Alright? So, what do? We need to find f of x. We need to find fx, the product of frequency and x. So this is what we're going to do. Now, the question here is, those values of x that were given here, these ones, they are just, they will be written as they are, 0 to 4, 5 to 9, and then the number of frequencies, we put the way they are, we were given, then we add them. That will be our n. Number of frequencies, n. When we add them, the total will be our n. And then the x value that we are talking about here is not the one you see here. The x value is not these values. The x value we calculate is ourselves. How do we calculate the x value? The x value is a midpoint. So we are going to say the midpoint of these two values, 0 and 4. What's the midpoint? So it will be 0 plus 4 divided by 2. That's the 2 we see here. 5 plus 9 5 plus 9 is 14. 14 divided by 2, that's the 7 you see here. And then you have 10 plus 14 is 24. 24 divided by 2, that's how you saw a 12 here. Just like that. 20 plus 24 is 44. 44 divided by 2. We have 20 plus, it will be 22. Okay, that's how we get, it is very important to know how we get the x value. Most students get challenges to actually get the x value. They end up using these intervals. Okay. So that's how we get the x value. And then in the end, at the end you get a total. So this total now, these two totals are the ones, the 80 and 1205 are the ones we're going to use to calculate the mean. So the mean x bar will be a sum of f of x divided by n. What's the n? The total number of the frequency. Okay. What f of x? The products, the totals, the sum of the products of f and x that we had. And then we'll get our mean to be a 15.3. Great stuff. Simple. So standard deviation is a measure of, so now we look at the standard deviation. So standard deviation is a measure of dispensation of a set of data from its mean. So if the data points are further from the mean, there is higher deviation within the data set. Standard deviation is calculated as square root of variance. So by determining the variation between each data point relative to the mean. Okay. So what we're talking about here is that standard deviation, we just want to see how the data that we've been given divert from the mean. How far is it from the mean? Okay. So we need to get the differences. So we're going first to standard deviation will be calculated as the variance, the square root of the variance. The variance is simply a difference between the value and the expected the expected value, or the mean. So first thing first, you find the mean. Those are the steps. You find the mean for, now step 2, for each data point, find the square of its distance to the mean. You square that. And then sum the values of step 2. Divide the number of data points by the number of data points. I'll show you in the calculations. Take the square root. Then we'll be able to get a standard deviation. So in formulas, S standard deviation is the root of the sum of variance. Variance is x minus c, the mean, squared over n. In other words, standard deviation can be described as the root of the mean of the squares of the deviation from the common mean of the set of values. So what do we mean? This is what we're talking about. Standard deviation can be the root of the sum of x minus, so the answer that we get inside there, squares. That's where we say the root of the mean of the squares. Alright, so standard deviation for a set. So we get to that example and see how we can calculate the standard deviation. So given 6, 11, 14, 10, 8, 11, and 9, find the standard deviation. Okay, how do we get a standard deviation? The first thing first, we need to calculate the variance. How do we calculate the variance? This is a table that will be very useful in calculating of a variance. A variance is the difference between the mean and the x value. So what we have is these values given here are the x values. So we write them like that. Okay. Now you can see in the formula there's x minus x bar squared. So what we need, we already have x, we can total it, and then we have x minus x bar. What is x bar? Mean. And we know that mean is equal to x bar summation of x over n. That's why you can see the total of x here. So the total of x is 69. Alright, divide by n. How many? 1, 2, 3, 4, 5, 6, 7. So when you divide that, we get the mean. Okay, you can see that the n is 7 there. So 69 divided by 7, we get the mean. So now we're going to be doing 6 minus the mean. We get this answer. This minus the mean, we get this answer. We get this one. And these answers, we square them. When we square them, we get 38.854. Now this 38.854 854 is the variance. Standard deviation is the square root of variance divided by n.